Hello, my name is Nilesh and I'm going to talk about support vector machine, one of the machine learning algorithm uh, which is typically used to classify handwritten digits based on the pixel values given as features. So the case study which was given to us is the goal was to develop a model that can correctly identify the digits 0 to 9 written as an image. Uh, so the database we use was MNSTN database, so which typically is from the National Institute of Standard and Technology, which consists of two files, MNSTN test and MNSTN train. The number of attributes about 785 attributes and about approximately 40,000 features, which is so each pixel basically had a single pixel value associated with it, indicating the lightness or the darkness of the pixel, which with higher numbers indicating darker and the lower ones indicating the lighter pixels. So the pixel value is an integer between 0 to 255. So we typically go through loading the data into the database and trying to do a standard check of data quality in terms of missing values, outlier treatment, standardizations, and dummy value treatment, and dummy value treatment as required. Post the data validation and EDA, we now try to build a model using the linear SVM and try to calculate the cost at C is equal to 1 on the full data set. Once we calculate the linear model, once we derive the linear model, we then try to predict the results and with the confusion matrix trying to arrive at the accuracy of the model. Since this is a huge data set, typically we require large computing resources, so it's always advisable to undertake the PC approach, because it will help us reduce the number of components which can run on a local machine on both the train and the test data set. So after running the PC or principal component analysis, we were able to prune the number of components significantly and then try to build a model. So the linear model now we were able to build at an SVM at the cost of C is equal to 1 and using confusion matrix to arrive at the accuracy, sensitivity, and specificity. Similarly, we try to build a linear model at cost equal to 10 and check on the accuracy, sensitivity, and the specificity. Since these are basic models, we also embark upon using RPF radial model kernels to predict the results for the model and try to evaluate using the confusion matrix the accuracy and specificity. Once the model has been built by three methods, we try to cross validate by using the hyperparameter tuning and cross validation. In case of a linear SVM, we calculate the cost. In case of non-linear, we calculate the sigma value and the cost value, and then in case of the RBF, we calculate the sigma and the cost value and try to match across the three models for the given test for the given data set, MNSTN data set. So in a nutshell, while comparing all the three SVM model for linear and non-linear method with the hyperparameter tuning and cross-validation, we derive at which is the most accurate models, which could help us predict the digits, the handwritten digits. So that's the usage of the SVM model that for machine learning.